Okay, so this is the second video in the explaining HTTPS video series that I have. In the first video, I went over I tried to explain how HTTP works as a process after having spent about 2 or 3 hours looking at different material, mainly the CS50 lecture by David Malin on HTTP, which is a great resource and available on YouTube if you want to see someone professional do this. What I'm doing now is, after having used the Feynman technique, which is basically to look at the source material, try to explain it to somebody, which is what I did in the first video, and then go back to the source material and then try to understand where your knowledge gaps were, and then after realizing where your knowledge gaps were, you try to fill those gaps with the material, and then you go back to explain that subject again, see if you're able to do it better, and then obviously that's a cycle that can repeat itself until you feel comfortable. The whole idea is that until you can explain something with simple terms and to somebody who doesn't currently understand the subject or doesn't have the knowledge already, then you probably don't understand it well enough yourself, and it's a way to expose those gaps in your knowledge so that you can replace that with the material and go through that process. So, just as one quick admission, I've recorded this twice already. Both times it broke because of QuickTime, and I think it was something to do with my screen going to sleep. But you're catching me after a week of having done it before. Apart from the Feynman technique, I've had no real extra insight, although I have been using the knowledge throughout the week in different exercises and just as I'm programming. So what I would say is that I actually found it the first time was easier, and I probably did a better job because it was more fresh in my mind. But the second time, and now this will be the third, at least the second time wasn't as easy. So maybe this is more of a test as to how easy it is to retain that knowledge after being able to do it in the first instance as well. I couldn't believe how different my knowledge was after probably the 2 hours of doing going back to the source material and then trying to present it to people. That was probably the amount of time I spent on it. So about 5 hours total, from going no HTTP experience to actually feeling quite confident in explaining it to somebody. So big success. I'm definitely going to use this in the future. Maybe I'll make more videos, I don't know. I'll get started then. So HTTP. First of all, I'm just going to explain that I've been doing a lot of programming from the command line, as maybe many people have when you first learn to program. You write a Ruby file, .rb, and then you put your source code into that file, and then you go on your command line and you do Ruby file.rb. That executes the code in your file. I'm just going to preempt this running out of battery. Pop in my charger and hope not to trip over that. That's what we've been doing up until now, and I've got lots of programs on my computer that I've been running off the command line. The question then is, how do we run a program when we don't have the files on our computer? So whether it's we've got an application like Spotify, or we're going onto a web page like google.com or facebook.com, obviously all of that information that we see doesn't sit on our computers because we didn't make it. So and we don't store everything on the internet all on our computer. So we must get it somehow, and if it's not on our computer, it must be on another computer. And what I'm going to be doing is explaining the process between the point of you going on your browser and entering a website and pressing go to search for that website, and then the content actually displaying on your screen. So I'm going to start with an analogy. David used it in his one, but this thing is so brilliant, and I'm going to build it out maybe a little bit more, or just kind of focus on it as I go through the explanation. Use it as a bit of a cue, which I found useful. So I want you to imagine that you are in the south of England, and in a time where there was no internet and no phones. Now, you know that there's an event going on in the north of England, but you don't know the details about the event. How are you going to find out the details? One little thing that might help you is that you've got a friend who's based in the north of England, you know where they live, and you can contact them, and they'll be able to tell you. Or the other option is to go up physically yourself and find out that information. But most people would write a letter, and they would request the information that the person in the north knew about the event, so where it's been held, who's going, what they should wear, directions to the actual location, all of that kind of good stuff. And when they send that information, that person will read it, and then they will, knowing the information, know what to respond to that request with, and then they'll send a letter back, and that will be how that person finds out the information that they originally needed or requested. So just to paint this out a little, just to spread it out a little bit more, the person sending the request in the first place, they're going to have two things as part of their letter. They're going to have the letter itself, and that's going to be a request for information. So I'd like information on the event. I want to know when it starts. I want to know the directions to get there, and I want to know what I should wear. But they also need an envelope because it needs to go through the system in order to, or the postal system to get to the person in the north. And on that envelope, they'll have an address, or they'll have a name at the top and an address. One thing to mention is that the name and the address is it's just a convention that humans at some point have decided that if you put a series of characters that resemble this particular pattern or style, then we'll interpret it to mean that you mean an address or a postcode or a zip code or whatever the case might be. So just something that humans have decided before. The address itself is an address for a physical location. I'm going to represent that with this little house, which is beautifully drawn. Okay, so, and this little man who's next to it, he's the person who knows. The house is, the postman will know where to go because it's got an address, and the address is a way to uniquely identify a physical landmark in the UK or the US or whichever country I imagine that you're in. It's something that is only is used to basically know where this house is in physical in the physical world. So when we write the address, we write for the request of information, and we send that to the person who knows. We're requesting that information from the person who knows. Now, it doesn't stop. Sorry, it doesn't go all the way there. I wouldn't expect a postman to pick it up from your local letterbox or your local post office and then drive it all the way to this person here in one go. I imagine that it goes from your letterbox to the local depot by where you live. That probably gets sent on to another local depot, maybe in the Midlands or the North, and then it goes to the local depot of the person who is going to be receiving the letter, and then the postman will take it from that local depot to that person's physical house. So I'm just trying to make the point that the route that the envelope will take, or the letter will take, is going to go through a number of different people or things before it reaches the ultimate destination, and that parallel, or that will become clear why I'm making that point, and I'll draw a parallel to the process for HTTP. Okay, obviously that at some point will come back and it will go down the same or similar route. It won't be the same route, no doubt, so it's not going to be the exact same person handling it, and it's not going to be the exact same footsteps that goes, but roughly it's going to follow a similar path in order to get back to the location. It's going to go through the same or a similar number of people probably. Okay, cool. The person who's received the letter, obviously they know the information that you need. That's why you're sending it to them. They know it, and they need to respond to your query or to your request. In order to respond to your request, they need to do a couple of things. One is that they need an address to send it back to you, so a name, an address, and a stamp. And then they also need the information that you required, right? Whether the party is at this location, and you'll be wearing, or you should wear, smart casual, or the directions from the station are you go, left on this particular road, and then straight across and Bob's your uncle. But but that's the kind of rough process that we have, and I've invested a little bit of time in going into this analogy just because I think it's such a clear way to understand this subject matter. So let's go through this then. So when we are, I'm going to introduce a couple of terms here. One is going to be client, and the other is going to be server. And I'm going to use another analogy of going to a restaurant to explain the relationship between a client and a server. When you're in a restaurant, we obviously usually use the name customer, but we could equally use the synonymous client of the business, and we will for this purpose. So when you go into a restaurant as a client, you look at the menu, you decide what it is that you want. Your waiter, who obviously is expecting you to make an order or to request something from the menu, is waiting for you, and then when that person, who again, at least in the UK, would probably use waiter more than server, but server is used across a lot of the world, especially in the US. So the server is waiting for you to request something, and when you do, it knows where to go, probably the kitchen, and it will grab it from the chef, and then once he's got it from, or she's got it from the chef, then she'll bring it back, or he'll bring it back, and then give it to the client. So the purpose of a server in this analogy, and indeed within this context here in HTTP, is to serve things. That's its purpose in life. Its name is well defined. A client requests. So a server will be sitting there waiting for a request. Once a client requests, then it will handle that request and will give the requester or the client what it is that they asked for. Alright, what is a client in this instance? When we're going on a website and trying to request a web page, it's a browser. It's your Chromes, it's your Firefoxes, it's your Internet Explorers, your Safaris, your Operas. I think Opera's one. I've not used it. I'm sure there are more, but those are some of the key ones. This is a poorly drawn browser. It's got a navigation bar at the top, which is slightly too far across, and you might put your Facebook.com in there, and then you click go, and then magically your newsfeed will pop onto your screen here. I'm going to give some explanation, hopefully, into how that magic happens. And even I've been studying software development. I've been doing it, part-time and in my spare time for a while now, like a good 6 months or so, probably longer, probably like 7 or 8 months. By now, and how little I knew about this was actually quite startling. So if you're, none of this makes sense, then I think you're in good company, or at least I was. And check out my first video of how little, even after watching the source material, I could explain to you. But the client browser is going to request something from the server, and given that we're working with the web, I'm just going to introduce another prefix to the server, which is web server. So a web server, what is a server? I asked the question, and I'll try and give you my explanation. A server is, like a lot of things I'm finding in this world, just a piece of software. So a server is a piece of software that, when run, listens for requests in order to respond with information. Its purpose in life is to serve, and once it's activated, then it will respond with the information once it's requested. I've drawn a hardware here, and the reason why is that obviously software has to be housed somewhere. So there is obviously somewhere where the software is loaded onto, or it exists. If you think of like a Facebook or a Google, you might have seen pictures of their data centers where they have big machines, and they're all really nicely lit, and they all look very high tech. That's obviously something that Facebook and Google can afford. But ultimately, it's just a piece of hardware where data is being able to store in it, and that data comes in the form of code and software. Okay, so we've got our browser, we've got our web server. Now, the browser needs to request the web page from the web server, because what you might have noticed when you are typing in your URL, I'm just going to draw this here. I'll probably get rid of it in a moment though. When you put into your browser www.facebook.com, you are requesting this web page. It's not on your computer, so it must be somewhere else. We know that we're in a client-server relationship or request-response cycle, where we are going to ask something, in this case a web server, we're going to request that we get the page facebook.com, and then that's going to return what this represents, which I'll go into more detail in a moment. But that's where we want to get to. We want to get to entering that to actually receiving the content. Now, I'm going to start with the envelope of the request. So similarly to how we're requesting information on an event here, we're requesting this particular domain. In order to get this to the location or to the web server, we need to uniquely identify it in the same way that we uniquely identified the address of this house by its physical address, zip code, postcode, and the street number and all that kind of good stuff, and the name of the person. In this case, we are putting the IP address on the envelope. So the IP address is very similar to a physical address, except that it is a way to uniquely identify computers or devices, obviously phones and printers and anything that is capable of being recognised within or by the internet or on the internet has an IP address. And there are some interesting things about how computers from the outside perspective can have the same IP address if you're in the same network. For example, if you're at home and your whole family is on one connection with a router, or whether you're at school or college or whatever, and there's a bunch of people going through the same network. So there's some interesting stuff that goes on behind there. But for the purpose of just explaining this, if you imagine that each device has a unique IP address that is able to uniquely identify it, then that's a good place to start. So we've got an IP address, and we also have a route number. I'm going to say it's 80 for now, and I'm going to come back and explain what I'm doing now when we get to the other side of the coin. So bear in mind, we also get another number here, which I'm going to put as 2662. Again, I'm going to explain that once I get to the TC part of this explanation. So we've got the envelope. We know where we're going. Also, another interesting thing is that the IP address, it's called Internet Protocol, and you've probably heard of it before. Probably aware that your computer has an IP address. What you may not be aware is that every domain name, which is just introducing a term for this this website address here, actually has an IP address. So you probably don't want to remember any number between 0.0.0.0 to 2525, 2525, 2525, 2525. These are the ranges that the IP address can be at, from the 0.000 to the 4 sets of 255 and anything in between. Remembering one of those is going to be difficult, but if you can imagine the number of websites that we go on, it would be absolutely ridiculous. We as humans need something much more semantically meaningful and easier to remember, and we've developed the domain name as a way to do that. Now, something that our computer does when we press enter is we run DNS, which will basically take the or the domain name, and it will spit out its IP address, which is what uniquely identifies the web server that you want to go to. So you type in facebook.com, but really your computer goes to the web server that the DNS spits out the IP address of. So that's something that is worth noting as well. But yeah, so we've got the. So he's using Twitter roll as a board wipe. I haven't got a board wipe yet. All right, so we've got the address sorted out, and now we need the request information. So up here we requested the information on a letter, and we used English and text in order to specify the things that we wanted to do. Fairly similarly, we use English and text to specify what we want to do, and we use it in the form of a HTTP request. I'm just going to introduce some other stuff here. So get homepage HTTP version 1.1, and then host facebook.com. Alright, so I'm getting rid of this bit just because that was just explaining IP and DNS. We'll keep this nice and clean. Alright, so it's probably not completely clear from there, but at least the wording, so I'll run through this. We've got a GET request, and this is not a massive document, but it's got more lines than what's under here, and I'm going to wave my hand at them, as David would say, which I quite like that phrase. I'm going to omit them for now, and just trust that they are doing stuff, but not stuff that we need to know about right now in order to understand the basics of HTTP. But we've got a couple of things here. We've got the word GET, and then we've got a slash, which you might not be able to see so clearly there, but it's like a slash is in HTTP colon slash slash. We've got one of those, and then we've got the word HTTP slash 1.1, and then we've got host as facebook.com. So it's going to explain what each of these are. Alright, so get is a verb, and it does what it says. Get information. Go get me something. And it's not too surprising given that we're in a client relationship and a client is requesting something. So in this instance, we're requesting to get something from the server. The slash just means homepage. So if you typed in facebook.com and you press go, what your computer does that you probably don't realize is that it will be going to facebook.com slash, which is the index page. I think that's just a convention. I think you could hard write it to be something else, I'm sure. That's almost definite. But for the large part, the default homepage is a slash. So get the homepage, and HTTP 1.1, all it's saying is, hey, I'm using HTTP version 1.1. Cool, and then host is, I'm just being explicitly clear that I'm looking for facebook.com. And the reason they do that is that sometimes web servers can host multiple websites on one server for performance or economic reasons. So we're just being explicitly clear. We want to go to this IP address, but we want this particular domain, facebook.com. Okay, so that's the request and the envelope. Hopefully I'm not missing anything out from there. I think that's it. And then we need to get from our client browser to the web server. And we do that through the internet. Okay, so what is the internet? It's a series of networked computers. So every computer that is connected to the internet is hardwired to be connected to every other computer on the internet. So there are cables that run all across the planet. They're insane how large and how many cables there are that are being created, laid, and used for sending information over the internet. It costs millions, hundreds of millions of dollars in order to lay a cable across the Atlantic, and there are so many of them. It's absolutely insane. Obviously we have wireless technology. I'm on my wireless laptop, so I'm connected to the internet, but I haven't got a hard wire. But obviously I get that from my wireless router, which itself is connected to the internet. And my phone is connected to some either the Wi-Fi, or it's connected to a some kind of tower that is transmission that, which itself will be connected to the internet. So there is no magic here. There's lots of wires that over time humans have invested huge sums of money, effort, and time into producing, and we send through that network of computers the information that we are trying to get to the place that it's going. So we've got a couple of different types of servers here. We've got our server, which is a computer. We've got our web server, which is a web server. This server listens and responds. This server is requesting, so the functionality is slightly different, but they are both servers. And then the third type of server is a router, which is something you've probably heard of before. A router, in the context of your home, is probably a little box that you have in your home office or somewhere that's got the connection that you need to the wall. You've got your router, and the purpose of that router is to take information from your computer and to send it to the internet. and then the internet, the information or the data that's coming back from the internet through your router is then to send it to your computer. So that's the purpose of that router, and similarly, the purpose of routers that are taking your information for the rest of the journey are very, are the same in the global sense. So similarly to how the postman doesn't take all of your post all of the way to the house, your router's not going to take all of the information all of the way. We've got there are thousands, tens of thousands of routers out in the world, and those routers' purpose in life is to to pass on data. How does it know where to go? It's got an IP address, so it takes the envelope or the request, and it looks at the IP address and the destination that it's going, and then it pushes it on. It just keeps on going, and then between you and the web server, there will be probably a number of different routers, and I think it's NS lookup. If you do NS lookup and then space and then the website from your command line, then you can tell when you request how many routers it goes through. I did it this week with Google.com, and it came up with at least 14, I think it was. So between us in the UK and I imagine California or somewhere similar where the Google data centers are, it was 14 routers that it needed to go through in order to get there. So that's really cool. We send this request. It's just a text-based document that goes through those routers, and the web server, whose purpose in life is to respond to information, to serve information or data that's been requested of it, looks at that information. And similarly to this person up here who knows what to send based on what words you used to request, this web server will know what it is to respond to your request with, based on your information in the request or the HTTP header, which is this document here. I'm not sure if I've used that terminology yet. This is the HTTP header. Okay, so it looks at it and it goes, "Oh, right, brilliant! You're looking for Facebook.com webpage." Now I know where Facebook.com webpage is, and I'm not going to go into massive detail in this little talk about what goes on behind the scenes there around databases and all that kind of stuff. Just for this purpose, I'm just going to kind of keep it a little bit higher level and just explain that your web server or the web server that you've requested from, if it has what it is that you're looking for, it will know where to go to get it. So in this case, in the analogy of the restaurant, the waiter goes to the kitchen and asks the chef says to the chef, I need a ham sandwich, and then the chef will give it back to them, and then they'll take it back and they'll pass it on to the user. So similar to that, to know the process behind it as an analogy to keep it really high level. But for now, I'm just going to assume that the web server has got the information, and it needs to do a couple of things. One is it needs a name and address to send back to you. Once it's got the information, it's got address wrong, but it's so illegible you can't even see that. And then it also needs the actual information, right? You want to know where to go to the party and all that kind of stuff. In this example, well, I'll give it to you. You want a web page, Facebook.com. Well, I'll give you all of the content that makes up the web page of Facebook.com, as decided by some human who has programmed this web server to respond to this particular request with this particular response. So that's something. Now, something that I didn't. I said I'd come back to with these routing numbers here is to explain a concept called TCP. TCP is Transmission Control Protocol. I'm just trying to think of the best way to. Actually, I realised I've not explained what HTTP is broadly. Maybe I'll do that towards the end, do it backwards. But for now, usually I would explain what a protocol is then, but I'll do it now. So a protocol is a convention. So a convention is something that humans have agreed upon at some point in time, and they follow as a way to keep some consistency across a group of people. whether it be deliberate or whether it just be by the product of people behaving in a particular way. So I'll draw a parallel to a non-technical convention, which is a social convention. And a social convention would be an instance where a particular behaviour is exhibited on the basis of it just being the thing that people do. So I'll use the example that David uses in his explanation, which is, if you got somebody and you go put your hand out and you say, "Great to meet you, my name's Rob," and then you would expect them, and it would be absolutely natural and almost awkward if they didn't respond to you with putting their hand out and also shaking it, and perhaps greeting you with a similar expression. So that's just a convention. It's just something humans at some point have agreed to do, explicitly or unexplicitly, and now that's something that we just expect. So when communicating with people, I expect to put my hand out and introduce myself. And I've kind of gone on to the explanation of HTTP at the moment. HTTP is actually, let me just, for the sake of clarity, I'm just going to continue with, I'm just going to explain quickly HTTP, and then I'll explain TCP. So HTTP is, that convention is, instead of me, it's a physical convention where I'm putting my hand out and someone's shaking it and saying, "Hi, my name is whatever." That's a physical convention that humans have decided, and a social convention in that sense. HTTP is not a physical convention. It's a convention, or it's a technical or digital convention by which the way that browser or clients communicate with servers. It's the the equivalent of I request something and then I get a response. So that's kind of the kind of core bit of the HTTP. TCP is also a protocol, so it's a convention, and it's just a convention that people have, or humans have decided at some point, that we're going to use particular numbers for routes. So not routes, ports. I keep saying routes. I don't mean routes, I mean ports. I feel like I've confused this a little bit, so if anyone is watching this and you're a little bit mixed up, apologies. I've jumped in and out of different terminologies there and maybe confused this a little bit. It's clear in my mind, but I don't know if I've expressed it in a way that wouldn't confuse somebody. Okay, let's continue. So we've got. Let me just quickly draw back to here so I can explain what TCP is. So this is TCP that I'm explaining. When we request on an envelope the IP address of a web server that we're going to make a request for a web page for, we also include two port numbers. One is port 80, that again can be different, but for this example it's 80. And one is more of a random number, there's less significance in this one, which is 2662. And these two numbers are telling the routers and the web server, it's telling the web server which port it's going to. So HTTP is by convention, so just something that humans have decided at some point, is number 80. So if I send something through HTTP, then I'm expecting it to go to the port number 80. So you can explicitly say this. You can, after your webpage, facebook.com, you could put a colon and then the number 80. I imagine that would probably not work because facebook.com, I believe, is HTTPS, which is the secure version of HTTP, so it's encrypted. And they use port number what's the number now? 424, I think. 424, 34. One of those two. It's 420 something. I think it's 44 or 43. I can't remember. But HTTPS uses a different port. Again, by convention, you can override that and you could do whatever you wanted. But developers across the world will be expecting that when they're sending something by HTTP, they're going to send it to port number 80. So it makes sense for you to conform to those agreed upon or the convention for those different port numbers. And the web server needs this number. It needs to know what request type you're making. And if it's 80, then it's going to assume it's HTTP. So I'm a web server, and I receive a request from somewhere, or a client, which is in this case a browser, and it's requesting information for the domain name facebook.com, and it's telling me that it wants to get some information. It wants the home page, and it is using HTTP version 1.1 and a whole bunch of other stuff. So as the web server, my purpose in life is to serve web pages. And because my purpose in life is to serve web pages, I know all of this information. Well, I might not if this stuff doesn't conform to what I have, but in this instance, for this example, it does. So I know you want to go to port 80, so I'm going to take that information after it's been routed to me, and I'm going to put it into port 80. And then, providing that information is sitting there, then I'm going to respond and send the information back to you. Alright, so the other port number, by the way, 2662, is a number that your computer generates. I use the word random. I think David describes it as pseudo-random, but it's less significant. It's just a number on your computer, because you can only run one application or web page or request response through the port at any time. If you try to run another one, then you'll get an error saying that it's already, I think it's bound is the terminology they uses, but it's already in use. So obviously you want to do more than one thing at once. You want to do loads of things at once, especially with multi-page. I've got about 100 tabs open at any one time. So the way that we handle that is that the computer generates a port for each of those activities, and when it sends that request for information, it tells the web server, hey, when you send that information back, send it to this particular port, which I've assigned specifically for this particular application or web page. So that's why we have that. And we're going to respond with, again, I'm going to keep with the analogy of envelope and the actual letter. The envelope is, let's see if I can remember this, because it's not as fresh in mind. It's going to be, there's going to be a status code, and then the word hopefully okay, and then, okay, I remember, HTTP 1.1, and then content type, text / HTML. Alright. Okay, so the response, again, sorry for the bad handwriting, but it's similar to this format. I've just combined it here. Maybe I should do the same here, just not too confusing. So this is, very similar in format to the thing here. So let's keep that kind of conformity. It's not exactly the same, because this is a request and this is a response. So the response has it can include loads of stuff, but the convention for where it will start will be, it will say what version of HTTP it's using. So, you're using HTTP 1, well, just let you know I'm also using HTTP version 1.1. And then it's got a status code, which I'll come back to in a second. And it's got the word OK, which means everything's OK. It all loaded OK, nothing wrong. And then a content type, which says text / HTML. So similarly to here, we're expecting the response to be in HTML or in text. And then we've got the words hello world, and then loads of other text, and that content is what goes at the bottom of the response header, which is what you're expecting for the content page to be in. Anyone who's ever looked at HTML, and if you haven't, then go to a website and then click in, if you're at least on Firefox and Chrome, and I'm sure the other browsers have something similar, click and go to inspect, or go to developer tools if there's another route to there. And go to go to the developer tools. And when you go to developer tools, if you go to the network tab, then you can see all of the incoming, outcoming traffic and the information that's being requested and responded to. And there's loads and loads and loads of stuff, and it's HTML, it's CSS, it's loads of different types of information that that you'll get, and then your browser will render or put together and display to you on your side, but that's what makes up Facebook.com or any web page. So Alright, we've got so we've got the response, the status code. So you're probably more familiar with this status code, 404, right? We've all seen it. That horrible page where you click a link perhaps, or you manually type out a website and it says 404 page not found. And what that means is that the request that you made for this particular page, let's say you made a spelling error and you put 0 instead of the O in Facebook, and you send that across, and the web server, because you've requested the IP address, it's received it, but it's saying that actually it doesn't have. Actually, I'm not sure if that would be. Yeah, if you put it, especially here, put 0. You want this web page. Well, I've not found that page because it doesn't exist on my server. So I'm going to respond to you with 404, which means that I've received the request. I've responded to you, but I'm letting you know that we don't have that. There's other ones. There's 301, which means moved permanently, and that might mean that you've typed in Facebook dot or you've typed in www.facebook.com, and Facebook, the human at facebook.com has decided that we're not going to be called www.facebook.com. We're going to be called facebook.com. So anyone who goes to www.facebook.com, we're going to send them a 301 and let them know the correct address, or the address that we've located or moved to, and then your browser would automatically go to that location. But if you look through the developer tools and the network tab to see the traffic, then you'll see that it actually made 2 requests. It made the request for the first one, it got the response saying it moved permanently, and then it made the request for the second one. Cool. Alright, so we've got the response. So yeah, let's just quickly recap. So I'm a client browser. I've requested a web page, and I've sent it through the routing process across the internet, or the interconnected computers or servers that has eventually reached the web server that I'm looking for, and it knows where to go because it's got an IP address, which is how we uniquely identify it. When it gets there, it also knows which port number specifically I want to plug it into, and then the web server, looking at the request, will go, okay, cool, so they want to go to port 80 and they want this information. They want to get the home page or Facebook, so they want to go to the home page as dictated by the slash. So I'm going to go and get that information. I'm going to go to the chef, I'm going to get the information, I'm going to return it to them. In order for me to return it to them, I'm going to send them in this envelope, or a HTTP header, which is the actual terminology, and I'm going to tell them where I'm sending it to in the IP address of this computer. I'm going to tell them which which port I need to go to with 2662, and then I'm going to send them a status code to let them know here's how the request went. Either it went 200 OK, or maybe I didn't find the page, so I put 404. I moved it, so here's the 301 and the actual location that you need to go to. And then here's all the content for when it's been successful that you'll need to render the page facebook.com or homepage. And then I send it back. Now something that I do when I send it back is really cool. This is really cool. Now that's again, anyone who's ever written any HTML, or if you go into that developer tools and you look at a fancy web page, there is so much stuff. It's so sorry, the screen keeps on going that it's gonna go to sleep, so I'm just putting it back on so it doesn't go to sleep. But there's so much information. There really is just an inordinate amount of information, and in order to send all that information without doing it all in once, because if they do, let's put it like this, if they do it all at once, they send every piece of information, then what happens if it gets to this route and it gets dropped? Maybe this router is overloaded because there are loads of people going through that particular route at that point, or a whole host of other stuff that could go wrong. Just like the postal service where your letter can get lost, routers, or the routing process, can also lose packages, and the similar terminology, it's called a packet. So they can also lose packets. And what you don't want to happen is, you don't want a request to be made, you send back everything all in one go, and the web server has got no way of knowing whether it's reached its destination or not, unless the browser pings it and says, you know, I've still not got this information, which I'm not even sure if it would do. Then it's got no way of knowing. But also, that's a big file to have to resend everything all over again. And you know, if that happens regularly, then that could over time accrue to be quite a costly process. So instead of doing that, we use something that's awesome called TCP IP. And TCP IP, so what does that do? TCP IP is a way that humans have come up with solving this problem of sending everything in one package. It's brilliant. They break it down into a number of smaller packages. So if we imagine we've got this envelope, then we cut it up into, or we've got the letter, we cut up the letter into 5 different pieces. And then we put them all into separate envelopes. So they're all separate packages that we are responding with. And then we send each of those packages through the routing process. They don't go through the same routers because they'll all find their own path, which means that, you know, it's highly likely that at least one of these packets is going to be getting there, right? You know, it's likely that if you send it all in once, it would still be getting there, but it's even more likely if you send a whole bunch of them. I'm sure it's much more than 5. If you send a whole bunch of them, and then at least one of them is going to make it to the destination. So, when you were at, maybe you're still at school, if anyone's watched this far, fair enough. If you, at least when I was doing essays, I would have like a essay 1 of 1, essay page 1 of 2, or 1 of 2, I've screwed this up. If I had an essay, if I had an essay, then I would label each page with, you know, a 1 of 10, a 2 of 10, you know, page 3 of 10. And then if I dropped those pages, I could really quickly work out which order they needed to go back in. And likewise, if I you know, counted them up and only had 9 pages, you'd be like, oh god, I'm missing a page. Which one do I need to reprint? And I'd be able to tell because you know, out of these 10, one of them is going to be missing, and it's going to tell me which number it is. So similar to how I would do that with my essays, if we're sending a response back and it gets back to the browser, and the browser looks at all the different packets and says, you know, you've said you've sent 10 to me, but I can actually only see 9, then it can make another request to the server and say, can you send me the 10th one? So the server then receives it, and it will go, okay, brilliant, I can send back the missing packet, I know which one it is, and I know what I need to send. So it sends that information back, which means that the web server is almost instantly aware that the package didn't make it, and also it knows that it only needs to send a small subset of the total package to avoid having to send one large and costly file all over that, all through that process again. So that's something else that's really really cool about TCP/IP. Okay, I think that takes us through the whole process, right? Once we get that information back to the browser will interpret the HTML and CSS files and will render that into the kind of user-friendly images and interactivity that we have on our website. Yeah, I'm pretty happy with that. I feel I got a little bit, I made it a little bit confusing with the HTTP and TCP stuff. But yeah, overall, I can't tell you how useful it was to do the Feynman technique. It's been really good. I've actually explained it 3 times because I explained it to one of my classmates, which I didn't record, but I went through that whole process again. And just each time I've done it, I feel that I'm really, like, there's a couple of things that came up this time that I realised that actually I wasn't too sure on, so I could go back and learn that information. And one of them was when I got confused between the routes and the ports, and I'd said that the web server knows which port to plug it into, and you know, at a high level, it might be easy to say that, but I'm not actually sure what that means. Does that mean that the web server receives the packet and then the information is sitting on port number 80 and it connects it to port 80? In fact, yeah, because I had our head coach makers explained it with a really good analogy where, well, that was a socket. It was I'll tell you the analogy. It was where you Actually, I can't remember it exactly. See, this is something that I need to go back to the source material. But if you watch the first video and see how absolutely lost I was, I literally couldn't even put the words on the board that I actually needed to describe. So it's been an incredible process. I'm going to be doing more of this, I hope, with some other concepts. I'm thinking about doing one for MVC. Might be the next one. So yeah, keep watching. If you watch this through, then thank you, and I hope it was useful. And yeah, thanks for tuning in.